Something is happening in the Red Sea that shouldn't be possible. Satellites are picking up anomalies spanning 200 square kilometers. Temperatures are spiking 5 degrees above normal. Entire biological systems are collapsing overnight, and the seafloor itself is shifting. Scientists cannot fully explain it, but this was described thousands of years ago. What is unfolding right now may be far from over. It's not just a stretch of water, it's a corridor, a narrow basin pressed between desert and mountain, squeezed by tectonic plates that are still pulling apart. Every year, more than 2 meters of water simply vanish from its surface, lost to the sky through relentless evaporation. That's one of the highest rates on the planet, and yet there is almost no rain to replace it. Only a slim connection at Bab el-Mandeb brings in new water from the Indian Ocean, and even that flow can slow or reverse with the slightest shift in wind or pressure. Most of the Red Sea is deep, but the northern corridor where Egypt meets Saudi Arabia turns shallow, unpredictable, and exposed. Unlike the open oceans, this basin is monitored by just a handful of buoys. 8 to be exact, scattered across hundreds of kilometers. Satellite images fill in some of the gaps, but clouds and dust storms can blind even the best sensors for days at a time. The result is a sea that can change dramatically, sometimes without warning and often without witnesses. Small variations, an uptick in wind, a drop in pressure, a shift in the rift below, can set off chain reactions that ripple across the entire corridor. In a place this finely balanced, the difference between normal and extraordinary is razor thin, and sometimes that razor edge is all it takes for the impossible to become real. August 2022. The Red Sea's surface temperature spiked to 33.4 degrees Celsius, over 5 degrees hotter than the seasonal average. Satellite sensors flagged the anomaly in real time, but on the water, the change was anything but abstract. Turbidity shot up, clouding the shallows in a murky haze. Within days, coral reefs along the Egypt-Saudi corridor began to bleach. The Egyptian Environmental Affairs Agency issued a rare coral health alert, warning that the Hurghada Reef was on the brink. Their bulletin cited a degree heating weeks index above 8, a threshold that signals mass bleaching is not just possible, but imminent. Coral ecologist Dr. Mona Sala described the scene as watching a city suffocate in slow motion. She recorded entire patches of acropora turning bone white, while just meters away, isolated colonies clung to life. The difference, she said, came down to a fraction of a degree, a thin layer of cooler water, or a lucky patch of shade. But most of the reef had no such refuge. By the end of the month, more than half the surveyed coral was dead or dying. This was not a slow-motion disaster. It was a biological shockwave triggered by a heat pulse no model had predicted, and the timing could not have been worse. The Red Sea's natural resilience, its ability to recover from heat, depends on stable inflow from the Indian Ocean. When that flow falters, even briefly, the entire system hangs by a thread. Life in the corridor was now at the mercy of forces no one could fully track, let alone control. And with every new anomaly, the margin for survival shrank. March 2025. The Gulf of Suez turned silent, but not in the way anyone expected. Chlorophyll, a lifeline for every marine food chain, collapsed across a 200 square kilometer stretch. Satellite readings showed a 68% drop almost overnight. The water, once teeming with microscopic life, now registered as a biological void. Sea surface temperatures jumped by 4 degrees Celsius. Salinity, tracked by a buoy at station RS-03, spiked by 0.6 practical salinity units. These numbers did not just break records, they shattered the models designed to predict them. Regional oceanographer Dr. Samir El-Jendi scrolled through the data, searching for anything that might make sense. Models based on decades of Red Sea cycles failed to anticipate such a synchronized crash. Upwelling, nutrient mixing, seasonal dust, none of the usual suspects fit. The official explanation from the Egyptian Environmental Affairs Agency blamed a coastal upwelling suppression episode. but Dr. El-Jindi's simulations, run with every known variable, produced nothing close to the observed collapse. And then, even the satellites went dark. Synthetic aperture radar, the only tool able to see through dust and clouds, suffered a sudden outage during the anomaly window. For critical hours, the region became invisible to remote sensing. No one could say for sure what happened beneath the surface. The science was clear on one point: the system had entered uncharted territory. But that was not the most shocking part. The real mystery was why every model, every forecast, and every expert failed to see it coming. Long before satellite feeds and climate models, a different kind of story haunted the Red Sea. In the ancient account, a sudden wind swept the waters aside, exposing a path where none should exist. For centuries, skeptics and believers argued over the line between miracle and myth. But in 2010, a team of physicists ran a simulation that changed the conversation. They set up a digital Red Sea, mapped its shape, and unleashed an easterly wind, clocking 63 miles per hour. For 4 hours, the model's corridor drained, bearing a strip of seabed wide enough for a crowd to cross. When the wind died, the water thundered back. This was not just a thought experiment. The numbers matched the biblical timing almost exactly. But the catch was this: everything had to line up perfectly. The wind speed, the basin's shape, the exposure window, missed by a fraction, and the path never forms. The simulation showed that under rare conditions, physics could mimic the story, but it also revealed just how fragile that window really is. The Red Sea's real-life wind events are erratic, their timing nearly impossible to predict. Modern records list only a handful of wind-set-down events strong enough to expose even a sliver of the floor, and none have lasted as long as the ancient account describes. Still, the model leaves a door open, a narrow one. If the right wind struck at the right moment, the impossible might not be so impossible after all. But that is where the certainty ends. Science can sketch the outlines, but it cannot explain why the pieces would ever fall into place. And as the Red Sea keeps rewriting its own rules, the line between natural law and ancient legend grows thinner and stranger with every new anomaly. March 2025. The Red Sea's northern corridor was stripped bare. Meter-deep water vanished in hours, leaving a salt-encrusted plain where there should have been waves. Satellite radar caught the exposed seabed stretching for kilometers. The event lasted just long enough for research vessels to scramble sensors and divers. Pressure gauges registered a 3-meter drop in sea surface height. Then, almost as suddenly as it began, the water surged back, erasing all but the faintest trace. On board the Saudi research ship, Dr. Khalid Al-Saeed watched the numbers spiral. He had tracked Red Sea rift activity for years, but nothing matched this. The drop was too fast, too deep for mere wind to explain. He pointed to a cluster of magnetic and gravity anomalies, subtle but clustered right beneath the exposed corridor. Fault lines, he explained, run like scars under the basin. Most drift for millennia, but sometimes a slip can happen in days. The Red Sea is a rift in motion, and its floor is not as stable as it seems. But wind alone cannot pull off a vanishing act of this scale. Nor can tectonics, at least not by themselves. Dr. Al-Saeed's working theory is a rare convergence. Tectonic subsidence, lowering the seabed just as a burst of wind and pressure set the surface retreating. The result was a basin-wide exposure, then a violent reflooding. The event left behind more than questions. It hinted at a mechanism no model had ever captured, one that could make ancient stories suddenly feel less like legend and more like a warning. This is where the mystery deepens. If the Red Sea can vanish and return in days, what else is possible beneath its shifting surface? Water has always been more than a resource in this corridor. Across civilizations, the sudden disappearance or transformation of rivers and seas has carried an unsettling message. Ancient texts from Mesopotamia to the Nile Delta warn of drying waters as signs of upheaval, omens that the natural order is about to be overturned. The Bible is only one voice in a chorus of traditions that link vanishing rivers to judgment, deliverance, or the end of an age. In the Red Sea, that motif is no longer confined to myth. Over the last decade, satellite feeds and agency bulletins have documented real, measurable events. Water levels dropping by meters in a matter of hours, corridors of exposed seabed, marine life blinking out and then returning in unpredictable patterns. Each anomaly is tracked, logged, and debated by scientists. But outside the labs, public reaction takes a different turn. Social media erupts with speculation every time a new image surfaces, a dry corridor, a heat map going white hot, a radar scan that does not match the last. Hashtags trend, comment threads split between natural explanation and prophecy. For some, these events are warnings. For others, they are proof that ancient stories are cycling back into the present, but the data is incomplete. The Red Sea remains one of the most under-instrumented major waterways on Earth. Buoy coverage is sparse, satellite windows are fleeting, and in situ, measurements vanish into institutional archives. Every unexplained drop or surge becomes a blank spot on the map, a gap where science runs out and speculation rushes in. The question is no longer just what happened, but what we are missing. To move beyond rumor and resonance, the next step is clear. More data, better coverage, and relentless monitoring. Until then, the line between anomaly and omen stays razor thin, and the world watches, waiting for the next sign. Beneath the surface, the Red Sea is rewriting its own rules. Science maps the changes, but the patterns refuse easy answers. As the seafloor shifts and ecosystems vanish, one question lingers. Are we witnessing coincidence or warning? The story isn't finished. Drop your theories in the comments below.